Hi, my name is Antony Simonet. I'm a postdoctoral associate with the Rutgers Discovery Informatics Institute at Rutgers University. In this video, I will discuss how to optimize the lifecycle of your data and of your experimental workflows. I will not talk a lot about fancy software, but rather recommend some good practices to make your work more efficient and safe. So first, what's an experimental workflow? It is simply the succession of steps you take to prepare an experiment, acquire data, analyze and compile the results. Experiments are all about collecting and exploiting data, which is why an experimental workflow is tightly related to the data lifecycle management. Then, what do we call the data lifecycle? The lifecycle of data is every step through which some data goes from the moment it is created to the moment it is deleted. For example, a file can be written, copied, modified, then deleted. Then maybe we need to define what is data here. Well, fortunately, this definition of lifecycle applies to any type of data you can think of: files, entire database, or just a record in the database, some objects in memory, or even packets on a network. A number of steps will happen to these types of data on the course of their existence. Finally, lifecycle management describes how data progress through the lifecycle, and there are two options here. One is us, humans. When we double-click on a file and edit it, we make the file progress to a new stage of its lifecycle. The first and most straightforward approach to experimental workflows is to do everything manually. People enter the data into a spreadsheet, apply some formulas, and point and click to generate a plot. The other option is programs. Instead of performing data management operations by hand, you can create scripts that do the same job, only much faster. So what's better, manual or automated data lifecycle management? If you take into consideration that I am a computer scientist, you may have an idea of which side I'm leaning to. Of course, it's better to automate your experiments, but let's see why. First, it's faster. Sure, there is a bit of a learning curve when you get started, especially if you're not comfortable with programming, but your efforts will be quickly rewarded because after you have scripted your experiments, running it will be as simple as clicking on a button. Experiments can be repetitive too. For example, when you want to observe how varying a few parameters affects your results. Scripting your experiments will allow you to easily repeat them thousands of times if necessary. Second, scripting your experiments is safer. It's safer because it allows you to take measures to back up your data and ensure its integrity along the workflow, like computing and storing the checksum of your files. From experience, people forget about these all the time, and the only way to make sure you have backups is to automate them. Another reason scripting your experiments is more secure is because humans make mistakes all the time. Say that you are running a program that spills numbers and that then you have to plot these numbers by entering them into a spreadsheet. Once in a while, I guarantee you that you will make a mistake entering those numbers and your results will be off. Scripting allows you to pass data from a program to another program safely. The last reason for scripting your experiments that I want to talk about is reproducibility, or the ability for others to reproduce your experiments and check your results. Reproducibility has always been important, but it is gaining even more interest nowadays with the open science trend that we are seeing in the scientific community. To ensure optimal reproducibility, researchers not only publish scientific articles, they also publish their data, the programs that produce the data, and the programs that analyze the data and produce the results, such as plots that are in the article. If you do this, researchers will be able to download your programs, replay your experiments, sometimes with different parameters, and get the exact same results you're getting without too much effort. With reproducibility comes provenance. The provenance of data is the information that indicates how it was produced. It includes which software, library, and version generated the data, what were the program's arguments, the operating system version, and so on. If you remember when I talked about data lifecycle, I said that it was all the steps that data goes through from the moment it is created until the moment it disappears. Well, you can think of Provenance as a super detailed record of the data lifecycle that will help people who access your data understand it and know if the data is interesting or appropriate for their needs. One of the time when Provenance comes in handy is when something goes wrong with your experiment. If you're ever in a situation when you realize weeks after running your experiment that there was something wrong and you made a mistake, you might want to go back and look at what you did to fix your mistake. If your experiment was scripted, you can look at your code and find where the problem originated. If you don't have that, you have to remember precisely what you've been doing, possibly months after the fact. Now that I have convinced you to stop using paper and spreadsheet to track your experiments, let's talk about a couple of tools that you can use to script it all. First, you will need a programming language. Obviously, this is a matter of personal preference, as any language will do. I use Python myself, and I recommend it if you don't know where to start because it is easy to learn and use. And with ecosystems like SciPy and Anaconda, it really comes with everything we'll need for scientific computing, data analytics, and plotting. Python is easy to install, but you can even start using it in your web browser with Jupyter Notebook, so there is really no excuse to not try it out. For analytics, I recommend checking Pandas and SciPy out. Pandas is loaded with API to facilitate data manipulation as arrays or matrices, while SciPy provides API for statistics, linear algebra, and more. Both of these integrate with Matplotlib for producing just about any sort of plots, including beautiful 3D visualizations and maps. That's all for this introduction to data lifecycle management. I hope you found it useful and that you will follow some of the good practices I recommended. Thanks for watching.